All right, let's just dive right in. Welcome to today's Explainer, where we're unpacking a really incredible new paper out of NVIDIA. So, if you're tuned into the AI space, you already know we've got text and image generation pretty much dialed in, right? It's lightning fast and looks amazing. But video? Man, video has been a totally different beast. It's been this massive bottleneck. Well, today we are breaking down a proposed solution to exactly that problem. It's a brand new framework they're calling flex forcing, and honestly, it promises to completely rewire how these models imagine and render moving pictures.
Now, to really appreciate what NVIDIA is bringing to the table here, we have to take a step back and ask, why are our current AI video models stuck in such a rigid rut? Like, why are we always forced to choose between speed and quality? Right now, if you're generating video, you're basically picking your poison. You can either have this beautifully consistent, cinematic clip that takes literally hours or days to bake, or you can have something that renders instantly, but it turns into this glitchy, melting nightmare after like 3 seconds. To see how flex forcing actually gets us out of this trap, we really need to look at the two heavyweights dominating the space right now.
Okay, so in one corner we have bidirectional diffusion models. I like to think of these guys as the ultimate perfectionist planners. When you prompt them for a video, they look at the entire timeline all at once, the beginning, the middle, and the end. And because they're operating bidirectionally, they are absolute masters at what researchers call global coherence and visual fidelity. So the background stays put, the lighting actually makes sense, and your main character doesn't randomly swap outfits halfway through a scene. But here's the catch, and it's a big one. They suffer from agonizingly slow inference. Since they have to constantly calculate and recalculate the entire video at every single step to keep it perfect, it takes absolutely forever to actually get your footage.
Then, over in the other corner, we've got autoregressive models. These are your speedy improvisers. Instead of obsessing over the whole video from the jump, they generate it sequentially, frame by frame or chunk by chunk. They literally just look at the frame they just made and guess what the next one should be. This gives you incredibly efficient streaming generation. I mean, you can basically watch the video pop up in real time. But because they're essentially just making it up on the fly, they are super prone to long-range consistency issues and this thing called exposure bias. In plain English, if they make one tiny mistake at frame 50, that error snowballs. By frame 100, your photorealistic golden retriever is suddenly this multi-headed monster. They just totally lose the plot.
So this really lays out the dilemma perfectly. The absolute best feature of one model is the kryptonite of the other. With the bidirectional approach, you get that stunning, globally coherent video, but you pay the price in those agonizing wait times. Switch to autoregressive, and you get the thrill of instant streaming generation, but the trade-off is your video eventually falling apart at the seams. For years, the AI community has treated these as two completely separate lanes. You just had to pick one and live with the downsides.
But I mean, what if you didn't have to choose? What if you could actually have your cake and eat it too? Well, enter flex forcing. This is the unified training and inference framework that the NVIDIA team just dropped, and it is explicitly designed to completely shatter that rigid either-or paradigm we've been stuck in. The whole concept is captured brilliantly in this one quote straight from the paper. They say flex forcing enables a video diffusion model to seamlessly operate under both bidirectional and autoregressive generation regimes. Basically, these researchers have cracked the code on how to build a single, unified AI model that acts as both the perfectionist planner and the speedy improviser all at the exact same time. It totally bridges the gap, so you're getting the absolute best of both heavyweights without hauling around their glaring weaknesses.
So how exactly does this work under the hood? It's honestly a super elegant piece of engineering. The secret sauce making this whole unification thing possible is a concept they call a flexible chunking mechanism. As the paper outlines, this is a core design that's jointly defined over the temporal axis, which is just the timeline of your video, and the denoising steps, which is that process of pulling a clear image out of static noise. Instead of trying to swallow the whole video at once, or blindly guessing one frame at a time, the model is smart enough to group the video into really manageable chunks.
And it breaks this down into 3 super clean steps. First off, it does that flexible chunking based specifically on your device's compute budget. So whether you're running this on some massive GPU server farm or a smaller local rig, the AI dynamically adapts the chunk size so it doesn't just instantly crash your system. Then, and this is where the magic really happens, it applies that slow, perfectionist, bidirectional method across the chunks for the big picture planning. It essentially locks in the overall structure of the scene. Finally, once that global blueprint is set, it switches gears. It uses the fast improviser autoregressive method within each of those chunks to just rapidly blast out the fine-grained details. It carefully builds the skeleton and then rapidly streams the flesh right onto the bones.
Now, the coolest part about this mechanism is the sheer freedom it unlocks.
Because the model is no longer chained to generating frame 1, then frame 2, then frame 3, it achieves any order, any time step generation without strict causal constraints. By ripping up those rigid rules of causality, the AI gets total flexibility. It can generate different pockets of the video auto-aggressively in whatever order actually makes the most sense at any given moment. And this is what drastically reduces that exposure bias we talked about earlier. Errors don't compound into a giant mess because the model isn't just blindly relying on the immediate past to guess the future.
And honestly, the verdict from their benchmark testing is just phenomenal. When they really put this thing through its paces, flex forcing delivers consistently higher video quality than older methods. It drastically improves stability for long videos, meaning yes, you can finally generate a longer clip without your subject slowly melting into the background furniture. And the craziest part, it does all of this while actually being faster to generate. It outright outperforms strong baseline models that rely on those older, rigid schedules. I mean, it is literally a win on every single front.
This framework is a huge deal. It completely changes the landscape of what's possible for digital creators. We're finally moving out of this era of agonizing trade-offs and stepping into a space where high-fidelity, totally coherent video can just be generated efficiently right on the fly. Which leaves us with one final, pretty exciting thought to wrap up this explainer. If AI can now plan globally with perfect coherence and generate instantly with blazing speed, what are you going to create next? Thanks so much for hanging out with me to unpack this one. I hope this deep dive made the mechanics of flex forcing crystal clear. Keep exploring and I'll catch you in the next explainer.